Welcome. So this is the last differentiation that you need to know for HSC Maths Advanced 2-unit, basically. You've got the trigonometric functions. So you have learned the 4 basic rules. You've learned the power rule, the chain rule, the product rule, and the quotient rule. And you have learned how to differentiate exponential functions, and you've learned how to differentiate logarithmic functions. The last thing is trigonometric functions, how to differentiate trigonometric functions. So we're going to do that for this particular lesson. So the rule for differentiating trigonometric functions is the differentiation of sine x is equal to cos x. Differentiation of cos x is equal to minus sine x. And the differentiation of tan x is equal to sec squared x, or sec x squared. Now, when we use the chain rule, we get this formula for when we're having something other than x, right? If it's not x, if it's something else, then we get this formula where you have the derivative of the function in front, and then it's cos of the same function. So for example, in this particular case, the function is 7x, right? Derivative of 7x. So the derivative of 7x would be equal to 7. So that comes out front. And then it's going to be cos, the function itself is 7x, so it's just 7x. And so derivative of the function times cos of the function itself, so just 7x. The same here in this situation. So you've got cos, so the derivative of cos would be minus. So in this case, this is going to be equal to minus. What's the derivative of 4x cubed plus pi over 3? Now, it's important to note that pi over 3 is just a number, pi being, the number 3.18, etc. So pi over 3 is just a number, so it's a constant. So when you differentiate, it disappears. All that remains is this. So this is 3 times 4, which gives you 12x squared. 3 minus 1 is 2, so it's squared. And then this multiplies by sine, right, from here. Sine, and the function remains the same, 4x cubed plus pi over 3. So that is the differentiation of cos 4x cubed plus pi over 3. What if we want to differentiate tan 5x minus pi? Exactly the same thing, except this time we're using sec squared. So the differentiation of 5x minus pi, again, pi is just a number. So 5x is the key component here. So differentiation of 5x is 5. So it's 5, and then it's sec squared and 5x minus pi. And that's it. Now, if one differentiates sine x degrees, this 0 here is not a power, this 0 here is a degree. Sine x degree here, that creates a little bit of problem, because all trigonometric functions, all these formulas here and here, these formulas are all based upon the idea that we're differentiating these sine, cos, and tan based on angles measured in radians. If the angle is measured in degrees, we're going to need to change them. Excuse me. So what I mean by that is we need to change the degree to radians and then differentiate. So if we look at the degrees, we know that pi is equal to 180 degrees. So pi radians as an angle is equal to 180 degrees. So pi radians as an angle measurement is equal to, pi as a number is 3.18, but pi radians as an angle measurement is equal to 180 degrees. What that means is that if I've got x degrees, I can convert that into radians and then differentiate, right? Because I can only differentiate if the angle is measured in radians, okay? So if I look at that situation there, what I know is that if pi radians is equal to 180 degrees, then if I've got x degrees, all right, then this should be, if I'm converted to radians, it should be pi x over 180. Okay, so it should be pi x over 180 radians. So this is what we should be using. So in other words, we can rewrite this as sine pi x over 180, right? And then we can differentiate this. If I differentiate this, I can use the same function here. So this would be derivative of this. What's the derivative of this? Just be careful here. You can break this up a little bit. You can break it up as pi over 180 because that's a fraction, and then x is separate. So that means that this is a number. So I can bring that out front. That's a derivative of it. So remember, if we derive a number, so that's the coefficient of x. So if we derive any coefficient of x, it becomes the coefficient. So if we derive 7x, it's 7. If we write minus 10x, it's minus 10, right? So in this case, if we're deriving pi over 180x, then it should be minus, it should be pi 180. So this would be pi 180. And using, because we're doing sine, using this here, it should be cos of pi x 180. Right? But we can now convert it back to degrees. So if I convert it back to degrees, it'll be pi over 180, and then it's cos x degrees. And that's our answer there. In short, you need to convert it to 180 degrees. You need to convert the degrees into radians. Pi is equal to 180 degrees. Once you've done that, then you can differentiate it and convert it back to degrees to write your answer. If that's a little confusing for you, maybe this one will be a bit easier. Sine squared x, we're going to need to use the chain rule. So sine squared x is the same as sine x squared. So using the chain rule, when we differentiate sine x squared, we take 2 to the front, and it's sine x to the power of 1, and we multiply by the derivative of the inside. So the derivative of sine x is equal to cos x, so cos x. So the answer here is that it's going to be 2 sine x cos x. In this particular case, we need to be able to split this up. There are 2 components here. We're going to need to use the quotient rule. This is u and v. Now remember, as I keep reminding you, please make sure you understand that all these rules, trigonometric differentiation rules, exponential differentiation rules, logarithmic differentiation rules, all of them do not replace your 4 basic rules. They are in addition to your 4 basic rules, your power rule, your chain rule, your product rule, and your quotient rule. So this is the quotient rule. And the quotient rule says that if you've got uv, then the differentiation of that would be equal to vu dash minus uv dash over v squared. So in this case, we've got u is equal to 3x plus 4. So u dash would be equal to 3. We've got v, which is equal to sine 5x. So v dash would be equal to 5 cos 5x. Now, when we put that into our answer, it should be v u dash minus u v dash over v squared. So if we look at these numbers here, v is sine 5x, u dash would be 3, and u is 3x plus 4, and v dash would be 5 cos 5x. And of course, v is equal to sine 5x. So if I put all that together, that's going to give me 3 sine 5x. In this case situation, you've got 3x plus 4 multiply 5 cos 5x. So that's 15. 3 times 5 is 15. 15x cos 5x. And the next one's minus 20 cos 5x all over sine squared 5x. You can put them two together. So let me just write that again. That's minus 20 cos 5x. Now you can see here that this is 3 sine 5x. This is 15x cos 5x and minus 20 cos 5x. Nothing is the same here, so you can't really simplify it. So we'll leave it as it is, like that. Hopefully this has been helpful for you. In trigonometric functions, again, just like logarithmic functions, do not be afraid to do the differentiation. It looks complicated, it's unfamiliar, but as you can see here, particularly 1, 2, 4, and 6, 5 and 6, they're quite straightforward. The degree one's a little complicated, but otherwise 1, 2, 3, 5, and 6 are quite straightforward. Thank you for listening to me.